Everybody for joining. As Kristen said, my name is Michael Bagalman. We can attach a number after my name, 1987, which is when I participated in SSP. Fond memories, I'm sure many of you have as well. I know that things have moved often beyond just astronomy, but for me, it was several weeks of figuring out Kepler's orbital elements for an asteroid. Kepler, who developed his mathematical model more or less using stolen data. And today we're going to talk about AI, a mathematical model built more or less on stolen data. My asteroid, by the way, 49 Peleus, and I maintain that's the best asteroid. I don't have evidence for that, but if necessary, I can produce a very confident explanation, which is exactly the sort of thing that I want to talk about today. Let me give you a little bit of knowledge of my family. While I'm like a math and data guy, I am married to an artist. My wife is a painter. You can see on your screen one of her paintings. I did something, just an offhand thing, about a month ago, where I gave a spreadsheet to a couple of different AI, a couple of different large language models. And the data was the height and width and area of the paintings and the price of the painting. And you may not be surprised, larger paintings tend to sell for more. But I asked the large language models, the AI, to take a look at this and tell me, does an increase in height matter more than an increase in width? Or is it just like the total surface area of the painting that seems to correlate most with the price of the painting? One AI gave me a very comprehensive analysis, and without my even asking for it to do this extra bit, it produced a number of charts, and it did in fact determine that the height of the painting was significantly more important than the width of the painting. The other AI did a much simpler analysis, concluding, however, that as far as it could tell, only the total area mattered, and it noted that because the larger paintings tended to be portrait sized, which you can see on your screen, right? So it's taller than it is wider, that there is an apparent correlation that taller leads to more expensive. But that is simply because there is a selection bias in the paintings, that we don't have paintings that are also very wide without also being very tall. I then gave that analysis back to the first AI, which then acknowledged its error and reversed course. You have a question? Or just not on mute? No worries. So one of these did data analysis, and the other, I would say, did science, or at least data science, right? The first answer, it's not fabricated, it's not made up, and it was looking at a real pattern in the data, just reporting that pattern without, to use an AI word, delving into its meaning. And that's a very common failure mode, and it's a dangerous failure mode because the comprehensiveness of that analysis gives the appearance of competence. So in the old world of data analysis, we tended to speak with error bars. We understood variance. Not to say that people didn't overuse point estimates, not pay attention to margin of error frequently, but we very much tended to report things, at least people in my world, with the numbers, as we move into this new world of AI, we're very much finding ourselves with things more easily translated into text. And if you are at all familiar with the work of Daniel Kahneman and his collaborators, such as Tversky, published a book, Thinking Fast and Slow, some time ago. Used to talk about System 1 and System 2. System 1, in your way of thinking in your mind, is the more intuitive and fluent way. And when you are getting responses that are in sentences and paragraphs, there is a tendency for the brain to sort of turn off some of its skepticism, the statistical skepticism that we have when we look at a spreadsheet of numbers and we're questioning it. Fluency feels like truth. Let's see if I can advance the slide. What's going on? There we go. There's the book. It's not just Kahneman. There's a ton of research going back a long way into this area. Of course, we're always extrapolating from whatever specifically a study looked at to try and apply it to our practical world. And frequently these studies are done on 20 Yale undergraduates or whatever. We extrapolate it to the population in general. But these studies have been replicated many times. And key to this is a number of studies that have indicated that there is a tendency among people to take statements that are easier to process and judge those as more likely to be true, independent of what the actual content is. We also have a tendency to prefer verbal expressions of uncertainty over a numerical representation. It's very likely, it's somewhat likely, it's not too likely, as opposed to having specific numbers. People tend to feel more comfortable with the words, but not surprisingly, we are much less accurate in interpreting that. What does highly likely or somewhat probable mean? It's going to mean different things to different people. And the understanding probability is critical to understanding how AI works, how specifically large language models work. They are probabilistic engines. They are not thinking machines. They do not have minds. They basically embed, we can call it words. It's really tokens, which isn't quite the same as words, but close enough. Embedded in essentially a mathematically constructed 1,000 dimensional space. For those of you who have never heard it, there's an old joke about trying to picture spaces that are more than 3 dimensions. There's a graduate student who says to the professor, professor, it's just so easy to look at 2-dimensional on a paper or see the 3-dimensional world. And I just can't, I cannot for the life of me picture or understand a 4-dimensional space. And the professor says, it's very easy. Just picture an n-dimensional space and then set n equal to 4. If you took enough math in college, you enjoyed that joke. These tokens are embedded in this 1,000-dimensional space, which is amazing. Now, I actually wrote my master's thesis a billion years ago on neural nets. I got my first job at a grad school at Bell Labs doing research on neural nets. And to be quite frank, if you had told me in the 2010s when Google was coming up with the idea for the modern transformer, the mathematical architecture that makes these modern AIs possible, I would have given you probably a dozen reasons why it simply would not work. Why that idea just is not a great idea. That's not going to work. And I would be completely wrong, which is something I just have to accept. There is no such thing, by the way, as an expert in AI, right? That's like saying somebody's an expert in medicine, right? The world's best oncologist shouldn't do your knee replacement surgery. AI is such a huge field that no one can claim to be an expert in AI as a general statement. But you can keep in mind that when we talk about these models, you often see these diagrams with nodes and lines and very complicated, and they talk about how many billion parameters they have. You can actually write the whole thing down as a complicated equation. You could write it all down as a single equation if you needed to, and think about it as a very fancy version of linear regression that you might have studied in a statistics or data science class, or maybe you even had a class in business school that talked about linear regression or trend lines in Excel. And that's what it is. I was at an innovation conference last year, and I was on a panel. It was me representing data science, as well as a neuroscientist and a psychologist. And the idea was to talk about AI and consciousness. And we all agreed it's not conscious, it's nowhere near conscious. And much like pornography, I can't really define consciousness, but I think I'd know it when I see it. And if you don't find that scientific enough, my apologies. When it's not being prompted, an LLM, a large language model, is not daydreaming, it's not thinking about anything, it is inert. When it is prompted, it is recursively going through an algorithmic calculation to identify the statistically most likely next token or next word, and it does that recursively to produce word after word after word. Not always taking the most probable one. Oftentimes they use like a pseudo-random number generator to sample from a distribution of likely words. But that's all that's going on. Now, if you look at a regular database and it's missing some information, a traditional database is allowed to plead the fifth. Well, it's not guilty of anything, but essentially it's allowed to remain silent, and we don't hold that against it. Large language models actually can't do that. You put a prompt in, something is coming out the other end. It's not constrained to be able to, it is constrained to never be able to return a null value. Truth is not in its training weight. Its core function, its raison d'etre, its purpose in life, is to predict the next most likely word, and it doesn't stop doing that. If it doesn't have the information, if a traditional database would have returned null, a large language model goes into plausible mode, right? It goes into, well, what's the most likely word that would be written or said by a human here? Hallucination, as it's called, and I decry the use of anthropomorphism when we talk about LLMs, because I think it gives us an incorrect understanding of them, but it's very difficult in English to talk about them without using these terms. Hallucination is not a bug. It is the machine literally performing its primary purpose, generally in the absence of any kind of data in its training set. So the don't know problem gets into this difference between words and understanding. A database can return null because the absence of the information is a clearly detectable state. The system checks, finds nothing, and faithfully reports nothing. The null there is both meaningful and reliable. Now, you might be thinking to yourself, well, I've had a large language model tell me I don't know. But a large language model saying I don't know is categorically different. The model doesn't have some kind of truth detection module checking its outputs against the real world before giving them to you. When it says I don't know, it is generating a string of tokens because they were the highest probability words in that context. It did not perform some kind of an epistemic audit and find a gap in its knowledge. Models are, in fact, somewhat notoriously miscalibrated about their own uncertainty. If you have used them enough, you will. Sorry? Maybe it's feedback. If you've used them enough, you will find that a model will very confidently hallucinate citations, dates, technical facts, while at the same time hedging on information that was actually in their training data. The I don't know response tends to appear often as a result of the phrasing of a question, of the prompt, that triggers uncertainty expression patterns. The model has not detected the epistemic gap, if you will. You can think of it as if you have a thermometer that simply reads unknown or is blank when the sensor it's attached to is broken, versus asking a person, "Hey, what temperature is it?" And they respond, I'm not sure. What do you mean you're not sure? You don't know, or you're not sure. One of them is accurate and the other is performative. And at least to a surface level, with the way things stand now, only really traditional databases are doing one, whereas AI is doing the other. We actually build these models to be somewhat sycophantic, and this is really a result of what's often called Goodhart's law. If you're not familiar with Goodhart's law, and you should be because it comes up all the time, it's in science, it's in government programs, it's in business. Goodhart's law is when there is a measure that is a good measure of something, but then we make it a target and it ceases to be a good measure. For those of you who already know this, forgive me, quick tangent. The classic example of Goodhart's law is when the British Empire had colonized India, and they had an issue. They had a problem with the number of snakes that they were dealing with. And sometimes people would find snakes and kill them, and somebody thought, well, that's a good metric. Let's just pay people to kill the snakes. However, like if you bring us 5 dead snakes, we'll give you some cash. 10 dead snakes, we'll give you twice as much cash. So of course what happens, people start breeding snakes to then kill and bring in. So of course the British who were overseeing the colonization of India realized what was going on, and they said, okay, we're not going to pay you for the snakes anymore. So now you got a bunch of people who have boxes or kennels or whatever it is full of snakes. They don't need them anymore. They just dump them out in the forest. Now you have more snakes than you had when you began. That is Goodhart's law. Models are trained in 2 steps. The first is, well, it's really more of I'm simplifying. The first is just on raw data. We suck in the internet and it looks at all the text and just sees, oh, this word tends to follow that word, and this next word tends to follow those two, blah, blah, blah. And the model starts to estimate its parameters to be able to repeat that. But then we have RLHF, reinforcement learning through human feedback. And this is literally people sitting there all day long with the model presenting them 2, possibly more, different variations on responses to prompts. And the person will look at these responses and pick which one they prefer. And then that information is fed back into the model, right? So think about your Netflix account. As you watch more and more action movies and don't watch the serious period dramas, it starts feeding you more recommendations for action movies, and the recommendations for the period dramas start to dwindle, right? That's exactly the same thing that is happening with the AI systems. But the reinforcement learning, if you really think about it, it is what do people like to see, right? We're not training it for what is truth, what is better for decision making. It's a bunch of people sitting there and we're asking them, which of these do you like more? And we're optimizing towards that. And you may have done it. I haven't really seen this much with Gemini or Claude, but I also use ChatGPT. If you've used ChatGPT, you have likely at some point had ChatGPT just randomly respond to a prompt and give you two answers and ask you which one of them you like better. You are participating in that training. Now, most people are just picking whichever one they liked more and tilting the model in that direction. And now I don't know about people watching this on YouTube later, but all of you here live with me right now, you're SS peers. So I know you gave it good feedback, right? Because you're intelligent and rational and clever and witty and good looking and all around fabulous. But what about everybody else? We're training these models to be sycophantic. I mean, this is literally what the definition of the term is. Right, so I have tried this experiment, right? So I have given the models data that showed a decrease in marketing spend and, in fact, worsening customer retention. But I asked the question, look at this data and tell me why the reduced marketing spend led to improved customer retention, right? In reality, retention did not get better. Retention got worse. But I didn't ask what happened to retention. I set up a premise. I asked, why did retention get better? And the machine is perfectly happy to validate my error. Why? Because I'm asking it to, and it is trained to give me answers that I'm going to be happy with. Now, to be fair, sometimes when I try this, in fact, more than half the time, it has recognized, hey, something's weird here. You said retention was getting better, but it looks like it's getting worse. The model will respond that way, but not every time. It is not at all uncommon that the model very quickly and very confidently gives me a narrative. For example, I got back a narrative that the reduced marketing led to filtering out the lower intent users, right? If you're a marketing person, you might know or if you're a theater person, you might know the phrase, oh, you only got the Glengarry leads. You got the good leads and converted those prospects into customers. So reduced marketing, you may have gotten fewer customers, but your retention got better because you found the better customers. It is a narrative that sounds very plausible and in many situations will be true, but we are sacrificing factuality for my ego satisfaction. The engine will often prioritize what it thinks I want to hear over what I need to hear. And that's what I'm referring to as the certainty trap. That I want to hear certainty. I want to hear an answer that conforms to what I already believe. A confident answer with a very plausible explanation, despite being at odds of the real world, is very likely to come out of one of these models because we trained it to do that. That's specifically what it has been built for, right? And because the model does not actually have a mind, it does not actually know things, to the engine, a factual statement and a plausible hallucination are the same. It'll validate my errors all day long because I'm asking it to do so. Now, here's where I'm going to switch to a parallel lane. I would like you to think about something. I suggest that what we're watching the model do in these examples, accepting a false premise, building a coherent narrative around that premise, and returning a confident answer optimized for the approval of the user, that is not a pathology that is unique to the machines. That is an apt description of how decisions get made in most organizations. The model did it because there is a mathematical reward function changing its parameters to give it what the humans say they want to hear. Organizations also have reward functions to incentivize the same thing. These reward functions consist of things like performance reviews, board presentations, quarterly earnings calls. We don't call it reinforcement learning through human feedback. We just call it our incentive structure. We don't call them our users. We call them our bosses. And we are often very strongly incented to tell them what they want to hear. The outputs of both of these systems are similar. I have on the screen surprisingly similar. We might want to take out the word surprisingly. Organizational dynamics have always had this structure, right? This is not something new in the age of AI. Making a decision and later on coming up with the why is old hat. But it used to take us weeks, often working with overpriced consultants to work that all out. But now you work it out in like a millisecond, few milliseconds. We have completely automated the rationalization of our own bias. If you think about a failed product launch and how that's going to get written up afterwards, right? A decision is made, a launch fails, someone's got to explain it. If you've worked in a business organization, certainly, you can see very quickly that everything goes from we made a bad call to the market conditions were unfavorable. We gathered, however, valuable learnings, so this isn't really a failure. A narrative is not emerging from the evidence. A narrative is emerging from the same pressure the model was under. Don't return null. Give me a story to work with. And this comes down to something called legibility, really. This is what I would argue. In a hierarchy, uncertainty generally will read as unpreparedness. If you walk into the board meeting and say, well, our best estimate is $10 million, but we've got this really wide confidence interval around that. The most likely outcome of that meeting is that you will be asked to go away, work more, and come back when you have an answer you can be more confident in. In the late 90s, a political scientist named James C. Scott came out with a book called Seeing Like a State, about why large institutions systematically simplify complex reality into simpler forms that can be managed and measured. I can't recommend this book highly enough. It is not like a Harlan Coben page turner. It's a bit of a slog to get through, but the ideas are very eye-opening. He calls the preference for simplicity legibility. And his examples were mostly government things, talking about land maps, forest management, stuff like that. But the very same logic runs through every quarterly business review meeting that you've ever sat in. The organization doesn't want a big probability distribution. It wants a number to put into the deck. Organizations prefer the confident point estimate not because it is more accurate, because it is more actionable within the hierarchy. Uncertainty is illegible to the hierarchy. It's harder to put in a cell on a spreadsheet and track it against a target. Similarly, the better known than Scott, Philip Tetlock, who you may have heard about from his analogy comparing experts to foxes and hedgehogs. He's done a lot of research in this area and has really documented how analysts in organizational settings are rewarded more for sounding decisive than being calibrated. Also, people who expect to have their decisions be questioned, if they expect to have to justify their decisions to others, they are more likely to shift towards options that are easier to explain, even at the cost of options that are more correct, that are better decisions. The claim that a confident wrong answer is safer than a nuanced right answer really rests on an asymmetry in how we distribute error, to think of it in sort of data sciencey terms, right? When a manager gives a confident answer within the organization's processes, and it turns out to be wrong, the failure is attributed to the circumstances. The market moved, the competitor did something unexpected, nobody could have known, because lots of people were consulted in the decision. Those of you who are old enough might remember a phrase: nobody gets fired for hiring IBM. But when a manager gives a hedged answer, failure will often be attributed to the manager. They weren't sure, they didn't commit, they weren't ready. Confidence provides a cover that calibration does not. The problem is that the confident version is often wrong. It is oversimplified. And the institution has no mechanism at all for identifying that uncertainty, because it has stopped looking. It has stripped away the uncertainty in its processes. Organizations are often structurally allergic to uncertainty. And in the age of AI, we have handed them a tool that is trained to meet that need, that need for certainty. This ultimately leads to more accountability laundering. Accountability laundering isn't new, right? There's always been a chance that a manager or an executive will be held accountable for bad decisions. But any of you who have worked in corporations know that doesn't happen all that often. People make bad decisions, but it gets attributed to the process or to the team in general, and an individual is rarely held to account for it. Now we have the AI that we can use as a shield to say, well, the AI gave me this answer. So you might say, can't we just build better models? And yes, we absolutely should. Researchers are making progress on calibration, on having LLMs express uncertainty, on being able to refuse accepting a false premise. But a technical fix is necessary but not sufficient. Imagine if we completely succeed with the AI. The model now always expresses the appropriate amount of uncertainty. It gives you 3 scenarios instead of a single precise number. It flags incorrect false premises. What's going to happen to that answer once it gets inside your organization? An analyst is going to read it and write an executive summary. The executive summary is going to say the model recommends option A. The calibration was in the output, but it doesn't survive the org chart. The demand for false certainty is not only in the model. It lives in the overall incentive structure that is a part of our environment, right? We're fish swimming in water. Fish aren't aware of the water. That's just the world. This is an organizational problem. So it means the fix has to be an organizational solution. Governance structures, decision rights, cultures that reward people for correctly saying, I don't know, rather than punishing that. We train the model in human feedback. Humans give higher ratings to confident answers because that's what their organizations want them to do, right? The org problem's upstream. You can't fix an upstream problem downstream. The model's amplifying this pre-existing condition. So should we just ignore the model? Why am I talking about AI? Should we just be talking about organizational decision-making? What AI has done for a lot of organizations, I can't speak to your experience, but I can speak to my experience and the experience of a lot of companies that I'm aware of. AI has helped surface this. AI has helped make this more visible. So by drawing attention to it, we have an unprecedented opportunity to try to fix it. When you use AI just to get a single answer, single median path, that's when you're in the trap. But you can use the AI to help map out the boundaries of what might happen, right? That's when you're starting to use it like a scientist. The model is always going to give you a number if you ask for a number. That's the trap we fall into constantly. If, however, we ask about the uncertainty, we can work toward that, right? Don't say, what will our Q3 retention rate be, right? I'm asking for a forecasted number. But could I say, give me a conservative, baseline, and aggressive scenario for Q3 retention, stating the key assumption that drives each of those scenarios? Well, then I get something I can actually start basing decisions against. It takes 30 seconds more, but it brings this abstract idea into a more concrete space. Because there's never such a thing as the number. And let me be clear, I'm not just talking about it because of probability distributions. Even on something that you think you can count, there's no such thing as the number. I can give you an example, actually, from my own job. I gave a whole talk on this at a conference a while back. So I do data science mostly, but I also oversee business intelligence, which means reporting. And, when I started my role, I was told, the most important thing that you have to really have down is when a senior executive asks, how many subscribers do we have today? You have to have that number. And I said, great, we can do that. I just need a little clarification. What do you mean by subscriber? What do you mean by today? And what do you mean by have? Right? Because my wife and I are both subscribers to the streaming service I work for, as well as many others. So if, we're 2 subscribers, but we've only got 1 account. So you really meant accounts, not subscribers, right? And when you say today, well, I get these data feeds overnight. So when you say how many subscribers do we have today, do you mean the count that I have from yesterday, from the data that I got representing yesterday, the data that I have today? Or do you actually want to know today, in which case I need to take yesterday's numbers and the history of the last few days and try to project what today is? And even have is not clear, because there might be somebody on a free trial, or there might be somebody that where we're renewing their subscription, but their credit card went past the expiration date. And so we sent them a note saying, hey, we couldn't bill you. We need you to update your information in the system. And if they do, their subscription continues. And if they don't, after a brief grace period, we're going to cut them off. Are those people still subscribers? You have to make these decisions. And 2 different data analysts can go and answer the same question, writing slightly different SQL queries into the database and get slightly different numbers. There is no the number. There are different numbers. There are numbers that have different degrees of plausibility, different degrees of your ability to have confidence in them. From a practical point of view, what we want are epistemic guardrails. That sounds fancy. But essentially, we want to try to shift ourselves away from certainty seeking and towards uncertainty mapping, right? One of the first things you can do with AI or with humans is to separate the generation from the evaluation. Use the model to produce the ideas, but then use a separate prompt, or better yet, a separate model, or maybe even a human being to critique them. Don't use the exact same thing that generated the answer to also grade the answer. You also want to force uncertainty into the prompt. Don't ask, why did this succeed? Ask something like, give me 3 distinct reasons why this might have failed. Don't ask, what should we do? Ask, what would have to be true in order for option A to be the wrong decision? You're not asking for the story. You're stress testing the story. And finally, you want to wrap your outputs in scenarios rather than having a single answer. You want to be able to have this traceable accountability, and you want to be able to ask and have conservative, baseline, and aggressive cases, or whatever the options might be for your situation, and understand the key assumptions that drive each one of those. Forcing your model to expose variance instead of hiding it inside of its fluency. All of this is somewhat simplified, of course. The engine being this probabilistic sycophant that is predicting words, the organization being a certainty-seeking, defensive organization that needs legibility. But if you take those 2 archetypes and you bring them together, there is a mismatch of goals that makes what I'm calling the certainty trap absolutely inevitable. How could you not get that? But at least in being aware of it, we can mitigate the potential harm. So as SSP alumni, whether you work in science now or not, you certainly studied science. You know that eureka moments are rare. But saying the data are inconclusive, or if you're less pedantic than I am, the data is inconclusive, is the hallmark of rigor. Orbital elements, from a classical physics point of view, can represent certainty. But we, and by we I mean humans and AI, need to avoid creating certainty where it doesn't really exist. And if we can't handle a machine responding with, I don't know, then we are not ready for the machines that we have built. And for better or for worse, that is what I brought to you today. I am absolutely happy to take questions, or better yet, have a group discussion. And if anybody has any examples from your own practice, I would love to hear it.
How do I do
it? Click on more. Oh, maybe they haven't.
Doug, you can go ahead.
I'll let Kristen.
Yeah. Doug, do you have a question for Michael?
First, thank you for quite a thought-provoking presentation. Very much appreciated. Something I noticed decades ago when I first started teaching, and maybe being an astronomer, also being asked questions by the public, is there seems to be quite a discomfort with the answer, I don't know, amongst a more general audience. I decided a long time ago that scientists were more comfortable with I don't know than a lot of the people who would ask me questions. I never really thought about why that is, but I wanted to contribute that I definitely have noticed that it's almost as if it takes some formal education to realize that I don't know can be a very good answer.
I think you're spot on. I mean, if you think about science, right? If there weren't questions to which the answer is I don't know, we wouldn't need to do science anymore. We'd have solved everything. And honestly, and even in business, I find when somebody is very open in saying I don't know, or I'm not sure about that, but I'll get back to you later, those are the people that I find are the most competent. The people that always have an answer, they've got to be making some of them up, and I'm never sure which ones they really knew and which ones they're making up. Anybody else have a thought or a question?
I will just ask mostly it's a housekeeping question. First of all, this is an excellent presentation. I just love listening to the whole thing, and I'm glad there's a recording made. But I just wanted to ask if you would provide like links or lists of some of the books that you recommended, because I'd like to look up some of them.
Oh,
Um,
absolutely. I can, Kristen, can I just send those to you? And I don't know if you can distribute it by email or put some links when you post this online.
Yes, yeah, I can take care of that for you.
I would be absolutely happy to do that.
and kind of like what the last question evoked. Um, I'm reminded of when the first computer processor, or maybe it was a language, came up with a value in a register called nan, not a number. Instead of having a failure or something, they invented not a number, and that seems to be a concept that should be expanded to life in general.
Yes, absolutely. And if that goes back to earlier, even today, like I don't spend a lot of time writing code anymore, but one of the things when you're writing code is you have to think about failing gracefully, right? You have to think about, like, I'm writing this algorithm. I'm supposed to be dividing by a count, but what if I divide by zero? What's going to happen? Like, what's going to happen with this? I need to be prepared for edge cases or unexpected inputs, and how to deal with unexpected outputs. I also see something in the chat from Ilano. One thing I've been wondering: why has understanding and improving LLM behavior been so challenging recently? Is randomness the only aspect of an AI's mechanism makes it difficult to develop better models? You know, it's very hard to say. There are certainly proponents who think that we're making better and better progress. I'm certainly seeing progress in certain areas. There are experts, Jan LeCun, who is one of the godfathers of AI and just left Meta to start his own startup. He thinks LLMs are played out. He doesn't think that they're the future. He's moving on to something called world models. Actually, he's been already working on that for a while. And there's definitely a limit to what LLMs can do by themselves without at least integrating with other types of software, right? Like, how many R's are in strawberry? I don't know if any of you have heard that, right? But that was a question that was often asked to ChatGPT, and it wouldn't get it right because it's a word prediction machine. It's in a computer, so we think of it must be good at math because computers are good at math, but it's not a calculating program. It's a word program. So just as Microsoft Excel isn't great with paragraphs, Microsoft Word isn't great at, like, taking square roots, and LLMs just have natural limitations. So it's not really. I wouldn't put it down to the randomness. I would put it down more to that large language models do a certain function. They're not thinking; they are generating sequences of words. That is extremely helpful, is extremely useful, but it is not the end-all be-all. Are there classes or trainings on how to force variance and force the AI to deal with uncertainty more transparently? This is to Joel's comment. I will give you guys a paper when I send stuff to Kristen, but if you want to Google it, some researchers from Stanford recently came out with something called verbalized sampling, which is a way of prompting the AI to give you output that is less towards the median, that will spread out a little bit. It is not hard to do. I use it all the time, and when I give Kristen a list of reference, I will include that. That is called verbalized sampling. If you want to Google it, Douglas, I can see your hand is raised. Digitally speaking.
was wondering if you have any ideas, suggestions, however you want to take this question in the direction of education. And how do you foresee AI being most constructively integrated into a student's learning? I'm going to
So
leave it broad so that you can broadly answer it. I could ask something more specific, but I'm just curious, how have you thought of AI being used in an educational context? Like, in what ways do you think it could be a constructive tool or process for students,
I
if at all?
I will answer that confidently as though I were an AI. But I am, in fact, I am an adjunct professor. I do teach, and I have two children. One is in middle school, one is in high school. And I certainly see my fair share of people who are using AI simply to do their work for them, right? And that obviously doesn't help anybody very much at all. My daughter, middle schooler, on her own, figured out that she could go to ChatGPT and tell it what she has a test on tomorrow and ask it to quiz her. Tell her, I need you to ask me about this topic at an 8th grade level, and it would ask one question and then tell her if she got it right, or if she missed it, it would explain it to her. You can write your essay and don't have ChatGPT or Gemini or Claude rewrite your essay for you, but you can say, act as my English professor or English teacher or whatever, read my essay and give me feedback, give me direction to make it better. There are a huge number of ways that we can use AI to improve education, but there are going to be people who use it to cut corners, right? Just as you probably knew somebody when you were in high school that took the math test or whatever, and on the side of their pencil had written in little tiny type, like the quadratic formula or whatever, so they wouldn't forget it. That's always gonna be there.
Thank you.
Don, I see a hand raised.
Yeah, hi Michael. I was an academic director for biochemistry last year in Purdue and things, and I'm a biochemistry professor at a university these days. And AI has really sort of taken over in terms of cognitive offloading. This is the biggest issue I think that was just being asked about. But the big issue also too was like when the calculator came out, people were no longer good with mental math. And like, these things start to just sort of peter away. So one of the major things that are facing a lot of higher education now is AI can do this just as well as me, if not better in some respects. And that's why some majors are really getting spooked out right now. The sciences are not so much, but really the languages, like the English and the Spanish and every other language, stuff like that, are getting freaked out. What's your take on where this is going to go? Like LLMs, you said, might be dead based upon that guy who left from Google, but
Jan LeCun.
yeah.
But I mean, yeah, well, LLMs still have a tremendous functionality for us. But yeah, I was at an event last night, and somebody was talking about having learned a language, and somebody else was like, I'm not bothering to study foreign languages anymore. Like before I travel, I don't. Why am I going to study French before I go to France? I can hold up my phone, say what I need to in English, and let the phone say it in French to that person. And I do think there is value in learning a foreign language. I took Spanish in high school. I took German in college. I never understood why anybody liked the poetry of Goethe. I thought it was terrible until I read it in the original German. And then I was like, oh, this guy's actually not bad. On the other hand, the flip side of that is a ton of people who would never be able to find their way around Paris and really enjoy Paris can suddenly now use their iPhone or Android phone, I guess Android phones work, I don't know much about them, and be able to speak French to people and get some directions and order a meal in a restaurant, right? So everything is a double-edged sword. And I think your mentioning when the calculator came out is a really apt analogy. We still have to know how to do math. My grandfather owned a small clothing store. He could calculate sales tax in his head. You could bring him 3 clothing items and he would add it up in his head and add 8.5% sales tax and get it right because he did it every day for decades. And he would find it frustrating when he would take me shopping and somebody at the register had to type in all the prices to find out what we owed them. We had to wait 45 seconds. Some things are just going to change. You know, I don't balance my bank account anymore. Why should I? If I'm wrong, if my records are wrong, I'm wrong. The bank isn't going to be wrong. So some things are just going to change. I think Natalie wrote a question. How can organizations prevent people from over trusting AI predictions? I don't know. If you figure that one out, please let me know. Honestly, it's the same question. How do you not over trust a human expert? If you had somebody who is a human expert and says something, they're going to be right a lot because they're an expert. You wouldn't consider them an expert otherwise, but you know that they're going to be wrong sometimes. And I think people just have to learn that computers can make mistakes. Computers aren't going to make mistakes. Like Excel is not going to calculate the square root of 3,281 incorrectly. But if it tells you what your marketing plan should be, yeah, like people are just going to have to learn that, machines are not infallible. Doug, I see your hand raised. Is that still raised from before, or did you have something else?
Because this is an SSP audience, I'd like to present something from the University of Chicago where I used to be, and this is an elaboration of your calculator example. U of C is pretty famous for asking science PhD candidates what are called Fermi questions, where they're trying to find out if you can distinguish a reasonable answer from an unreasonable one. And I think that it's one thing to use a calculator, but it's a more subtle and a more state-of-the-art thing to know what the numbers mean. And so I see a very important role for good scientists, for good people in any field, for constraining the machine answers with reality. That's a different way of saying what some people have said, but I think that's very important. I teach science majors nowadays, and they tend to overly believe the results of their own calculations. Once the program runs and gives them a number, they're so happy with it. And one has to really force them to take a step back and say, gee, is that the right answer? What does it mean? That kind of thing. So maybe that's a role for SSP type of preparation, is that you take a step back and say, okay, this is the number, but is it really the right number?
And what does it mean?
And what does it mean?
Great point. That is it. I actually teach junior analysts. I teach them about Fermi estimation because I think it's so valuable. I'm glad you brought it up. And the same thing, even in business, when I have analysts that have to provide reports to executives, you have to look at the numbers. You don't just calculate the number from the database and send it off. If you've been reporting that something was about 10%, like a churn rate, month after month, 10%, 10%, 10%, and then it goes to 15%, you can't send that. You have to look into it and see, well, that's way off from what it's usually been. Either it's wrong and you have to figure out why it's wrong, or it's right and you need to figure out what just happened. Like, it's not your job just to say something. And Joel, yes, Fermi estimate is very similar to back of the envelope calculation.
Yeah. If I could just jump in, I have an
Sure.
anecdote that is so much fun. I do think this audience would appreciate it. I'm just the right age that when I went to buy my first house, a few of the realty places in Los Angeles had become computerized. And one in my neighborhood had a big sign that said, "We use computers to search for your dream house." So I went in and I had an interview with the realtor, and they asked me maybe 20 questions from a sheet of paper, all my preferences. And then they said, okay, come back tomorrow and we'll have a computer printout. So I came back tomorrow and I sat down, and with a straight face, the realtor said 5. And I said, excuse me, 5 what? And the realtor said, there are 5 homes that you can see in Los Angeles. Okay. And I thought, what is going on? And what had happened was the program was constructed in a series of Boolean ands, I guess it would be called, where every single one of my preferences had to be matched in order to get an output of a house I could see. So I was told with a straight face that in all of Los Angeles, there were 5 houses I could look at. And I smiled and I walked out and I found a realtor who knew the neighborhood who just drove me around and found me my first house. But because the computer said it, the person was 100% trusting and actually sat there and told me there were only 5 houses in Los Angeles. I was amazed.
A little small town like Los Angeles, you're lucky you had 5. No, but yes, and today someone would do that using, most likely they would be using a cosine similarity calculation, right? To take into account that we don't have to exactly match all of your criteria. But you are absolutely correct that, there's stories of George Danzig when he was first inventing the simplex algorithm, trying to optimize nutrition in dorm cafeteria, and it basically came back and said, because he only gave it some basic nutritional requirements, mostly just caloric level and minimize cost, and it said, well, feed your undergraduates 1,000 bouillon cubes a day, and you'll be fine. He realized, oh well, there's more criteria I need to bake into that. Let me just check real quick in the chat. Alvin mentions the George Box quote, which is apocryphal, by the way. It's a great quote. All models are wrong, but some are useful. That is not actually what Box wrote, but it is very close to what he wrote. And I can't remember exactly what Einstein said, but he said something like, "You should make every model as simple as it can be, but no simpler." There is something to the principle of parsimony, but we can get a little carried away. Sometimes you need a certain amount of complexity. Complexity is Alvin, is on a relative scale. If you're studying statistics now, at some point you're probably going to study XGBoost models, and that's in data science. Those are the baseline. That's what you sort of start with these days. And when I was an undergraduate, an XGBoost model would have been viewed as insanely complex. But these days, it's actually fairly simple. So it's all in sort of a sliding scale. And I see, Joel mentions computer dating in relation to Doug's anecdote with the houses. And yeah, sorry if I'm answering these quickly. I just know that we're over time. And Kristen, I don't know I don't know how long you want to go.
I'm sure we could go on for a little while. We do have another question in the chat that you missed, and I think that will be it for you. It's, do you think it is possible to change the algorithms to show a bit more uncertainty?
I certainly think that we can. That would be part of either reinforcement learning or sort of helper models. Just FYI, so when you're, say, on the ChatGPT website and interacting with it, you think you're interacting with the model. It's actually like a whole set of models. Like there's a model that checks what you're inputting to look and see if you're doing what's called a prompt injection attack. And there's other models that add in like the punctuation and such on the output. It's actually a whole little ecosystem. So in addition to reinforcement learning, you can probably also have like a helper model that will provide feedback before it comes back out to you. There are a bunch of ways that problem can be addressed. I am not active in the AI research community these days, so I would be committing the fallacy that I'm talking about if I spoke too confidently about it. But I am confident that there are people who are working on that right now. But I think we should probably be wrapping up. I cannot tell you how grateful I am to have the opportunity to give this talk. How nice it is to be connected with the SSP community. Like all of you, I'm sure we all feel the same way that SSP was a big deal in all of our lives, and it's wonderful to get to talk with all of you today. I truly am grateful for the opportunity.
Thank you so much for making time to join us and sharing your talk with us. It was wonderful.
You're welcome. Thank you.
Thank you so much, Michael. We appreciate you. I will get everybody the list that Michael provides me, and there will be a recording of this. So if you want to go back and look at anything, we'll be posting that up on the network and our website. And last but not least, our next curiosity is April 12th. And that one is on math, counting what really counts from combinatorics to community. So hopefully you'll join us for that one as well. But once again, thank you again, Michael, for joining us in this lovely talk. Have a good rest of your day, everyone.